Imagine waking up tomorrow and discovering that the world you live in is just a tiny fragment of a much larger reality. That everything you know, space, time, even the very laws of physics, are just shadows of a deeper hidden structure that we can't directly perceive. What if the universe is far more complex than we ever imagined, extending beyond our three-dimensional experience into realms we can barely begin to comprehend? For most of history, we thought reality was simple. We move in 3 dimensions, and time pushes us forward. But what if that's not the whole picture? What if there are entire dimensions wrapped around us, hidden yet influencing everything? And what if unlocking their secrets could change everything we think we know about the universe? Think about this. Gravity, the force that keeps you grounded, is incredibly weak compared to other forces like electromagnetism. Why? Some physicists believe gravity may be leaking into extra dimensions, dimensions beyond the 4 we perceive. Could this explain some of the deepest mysteries of the cosmos? Some scientists propose that reality isn't just 3 dimensions plus time. It could have 10 dimensions or more. If that's true, then our entire understanding of existence is incomplete. What we see, touch, and experience could be just a slice of something far greater. So what happens if we find a way to interact with these hidden dimensions? Could we travel through time? Could parallel universes exist alongside ours, just out of reach? Could forces beyond our comprehension shape our consciousness itself? The deeper we go, the stranger the universe becomes. Because once you truly understand what these extra dimensions mean, you may never see the world the same way again. Keep watching, because what you're about to learn will challenge everything you think you know about reality. For centuries, we've thought of reality as something simple, something we can see and measure. We exist in 3 dimensions, length, width, and height, and time moves in a single direction, from the past to the future. This is the world we experience every day. But what if that's just an illusion? What if the reality we see is only a fraction of something much larger, something that extends far beyond what our senses can detect? Modern physics has shattered the idea that the universe is limited to what we can perceive. Beneath our everyday experience, the fabric of reality is far more complex. Scientists believe that extra dimensions, hidden dimensions, may exist all around us, shaping the way the universe operates in ways we can't directly observe. They may explain some of the biggest mysteries in physics, from the strange behavior of quantum particles to the true nature of time and space itself. To understand why these extra dimensions might exist, let's start with what we already know. We live in a 3-dimensional world, meaning that every object has length, width, and height. If you add time as a 4th dimension, you get a 4-dimensional framework called spacetime. This is the model Albert Einstein described in his theory of relativity, which explains how time and space are linked and how gravity influences them. But here's where things get strange. Gravity, the force that keeps us on the ground and governs the motion of planets, is incredibly weak compared to other fundamental forces, like electromagnetism. You can lift a paperclip with a tiny magnet, even though the entire mass of the Earth is pulling on it with gravity. Why is gravity so weak? One possible explanation is that it isn't weak at all. It's just being spread out across extra dimensions that we can't see. Imagine an ant walking on a tightrope. To the ant, the tightrope appears to be a 1-dimensional path. It can only move forward or backwards. But if you look closer, you see that the tightrope has a 2nd dimension. The ant could, in theory, move sideways around the rope. Now imagine that our 3-dimensional world is like that tightrope. We perceive only 3 dimensions, but there could be more, dimensions that are curled up so small that we don't notice them, just like the ant doesn't notice the 2nd dimension of the rope. These extra dimensions are a key part of string theory, which suggests that the fundamental building blocks of the universe aren't particles, but tiny vibrating strings. According to string theory, these strings vibrate in different ways to form different particles, and their vibrations are influenced by the extra dimensions they move through. In other words, the structure of these hidden dimensions determines the properties of everything in our universe, from the smallest atoms to the largest galaxies. If these dimensions exist, they could also explain some of the strangest aspects of quantum physics. At the quantum level, particles behave in ways that seem impossible, like existing in multiple places at once or changing state simply because they're observed. One possibility is that these weird effects happen because particles are moving through higher dimensions that we can't see. If true, that would mean our entire reality is just a shadow of a much larger, higher dimensional space. But what about time? We experience time as something that moves forward, always flowing in one direction. But some scientists believe that time might actually be more like space, meaning that the past, present, and future could all exist simultaneously, just like different locations in space. If that's true, then time travel might not just be science fiction. If we could access higher dimensions, we might be able to move through time just as easily as we move through space. And if that's not strange enough, some physicists believe these extra dimensions could be home to parallel universes. Imagine that our universe is just one sheet in a stack of many sheets, each representing a different reality. If we could somehow move between these dimensions, we might find ourselves in an alternate version of our own world, where history unfolded differently, or even where the laws of physics are completely different. The deeper we go into these theories, the more questions arise. Are we truly bound to just 3 dimensions of space and 1 of time, or are we part of something far greater, an intricate, multi-dimensional universe that we've only begun to understand? Could civilizations be living in these extra dimensions, just outside our reach? And what happens if we ever figure out how to interact with them? One thing is certain: reality is not as simple as it seems. The universe is far stranger, far more mysterious, and far more complex than we ever imagined. The more we explore these hidden dimensions, the more we realize how little we know, and the journey to understanding them is just beginning. If the universe is truly 4-dimensional, 3 of space and 1 of time, why do the laws of physics suggest otherwise? Why does gravity behave so differently from the other fundamental forces? Why do subatomic particles act in ways that seem completely contradictory to our understanding of reality? Could the answer lie in dimensions beyond the 4 we experience? Let's start with gravity. We experience it every day. It keeps us anchored to the ground, governs the movement of planets, and even dictates the structure of galaxies. But there's something odd about it. Gravity is incredibly weak compared to the other fundamental forces of nature. The electromagnetic force, for example, is 10 to the 36th power times stronger than gravity. That's an unimaginable difference. If gravity were even a little stronger, stars would burn out too quickly. If it were weaker, galaxies wouldn't hold together. But why is it so much weaker than everything else? Could it be that gravity isn't really weak at all, but instead it's leaking into extra dimensions? String theory suggests that gravity might not be confined to our familiar 4-dimensional universe. Instead, it could be spreading out across additional dimensions, dimensions we can't directly see. If that's the case, then what we perceive as weak gravity is just a fraction of its true force, diluted across a much larger cosmic structure. But gravity isn't the only mystery. Consider the behavior of particles at the quantum level. In the world we see, objects exist in specific places at specific times. But quantum mechanics paints a much stranger picture. Particles don't seem to have definite positions until they're observed. Before that, they exist in a state of probability, essentially being in multiple places at once. How is that possible? Why does measurement collapse a particle's uncertain state into a definite one? Some scientists propose that extra dimensions might be influencing these quantum effects in ways we don't yet understand. And then there's time. We think of time as a straight arrow, moving from past to future with no way to go back. But relativity suggests that time isn't so simple. Near a black hole, for example, time slows down dramatically compared to a distant observer. If you could hover just outside a black hole's event horizon, you'd experience time at a fraction of its normal rate. Decades could pass for the outside universe while only minutes tick by for you. Could this warping of time hint at deeper dimensions that govern how time itself functions? Another problem. Our universe seems fine-tuned for life. The values of physical constants, such as the strength of gravity, the charge of an electron, or the expansion rate of the universe, are so precise that even the slightest change would make life as we know it impossible. Why do these constants have the values they do? Why this universe and not another? One possible answer is that we are just one of many universes in a vast multiverse, each with different physical laws. If higher dimensions exist, could they be the key to accessing other universes? Some theories suggest that our universe is like a 3D bubble floating inside a higher dimensional space. Other universes, other 3D bubbles, could be floating right next to ours, separated by just a fraction of a millimeter in an extra dimension. If that's the case, is it possible to interact with them? Could advanced technology one day allow us to peer into another universe? And what about black holes? These cosmic monsters are among the most mysterious objects in existence. They warp space and time to such an extreme that nothing, not even light, can escape once it crosses the event horizon. Some physicists believe that black holes could be gateways to other dimensions. Could falling into one lead to another universe, or do black holes themselves exist partly in extra dimensions? Then there's dark matter and dark energy, the invisible forces shaping the cosmos. Dark matter makes up 85% of the universe's mass, yet we have no idea what it actually is. It doesn't emit light, doesn't interact with regular matter the way we expect, and only reveals itself through gravity. Could it be that dark matter is ordinary matter trapped in another dimension, its gravity spilling into ours? And dark energy, the force causing the universe to expand at an accelerating rate, could it be an effect of forces acting on our universe from higher dimensions? These aren't just abstract questions for physicists. Understanding extra dimensions could change everything. If we could somehow perceive or manipulate these hidden dimensions, it might revolutionize technology, energy, and even our ability to travel through space and time. So where do we go from here? The next step is to break down these dimensions one by one, to start small, with the simplest extra dimensions, and gradually work our way to the mind-bending possibility of a 10-dimensional reality. If higher dimensions exist, what do they look like? How do they behave? And most importantly, what do they mean for us? That's exactly what we're about to explore. Let's start with basic thing which we know. The first 3 dimensions. Let's break it down from the very basics. Imagine a single point in space. This point has no width, height, or depth. It's simply a position in space with no measurable size. Now, if you take 2 of these points and connect them, you form a straight line. This is the essence of the first dimension. A line in this dimension only extends in one direction. There's no width or height to it, just a sequence of points strung together in a single straight direction. The first dimension might seem like an abstract concept because in our everyday lives, we don't experience anything that exists purely in this form. However, this simple one-dimensional line sets the foundation for everything that follows. It is the basic building block that leads to the creation of more complex structures. When you add a second point to a line, you start to form something with a sense of direction, moving either forwards or backward, left or right. It becomes clear that even in this simple form, something more intricate is possible. Now, let's move on to the second dimension. To visualize this, imagine you have that same line from the first dimension, but instead of just moving along that single direction, you add another direction, creating a flat plane. In the second dimension, everything exists in 2 directions, length and width, but still no height. Think of this as drawing on a piece of paper. The image on the paper, whether it's a square, a circle, or a triangle, has width and height, but it lacks any depth. This flat world of the second dimension is a bit closer to the world we live in, but it still doesn't represent our full physical experience. In this 2-dimensional world, everything is confined to the flat surface. There's no up or down, just left and right or forward and backward. These 2 directions combine to create all the patterns and shapes you encounter on a flat sheet. But despite its simplicity, The second dimension gives rise to all kinds of possibilities. Two-dimensional objects, like squares or circles, exist entirely within it, without any awareness or interaction with the third direction. This world, while flat, would still be a complete and functional system if it were to exist in isolation. However, this is only part of the story. When you fold this two-dimensional plane upwards, you step into the third dimension, the space we inhabit. This is the dimension of height, width, and depth, the full experience of space. Now, instead of simply moving along a flat plane, you can move in multiple directions. You can move forward, backward, left, right, up, or down. The third dimension introduces volume, allowing us to create and experience three-dimensional objects, things like cubes, spheres, and pyramids that have depth, height, and width. The third dimension is the space where all of our physical existence occurs. It's the world we can touch, feel, and navigate. The houses we live in, the streets we walk on, and the objects we interact with. Everything exists in three-dimensional space, but it's not just about the things around us. Our experience of time and movement is also framed within this dimension. In three-dimensional space, we can think of movement as occurring along three axes: forward and backward, left and right, and up and down. This tridirectional framework shapes the way we understand how objects and people move through the world. One of the most fundamental aspects of the third dimension is depth. Depth allows us to perceive how far away something is, how close it is, and how large or small an object might be. Without depth, everything would appear flat, like a two-dimensional drawing. But with depth, we can perceive the full volume of objects around us. Think about a chair in a room. Its depth, height, and width allow us to see its full form. If you remove depth, that chair would look like nothing more than a series of lines on a page. The third dimension also brings complexity to our experience of time. While we usually think of time as a separate concept from space, the two are closely intertwined. Our experience of time is influenced by the way we move through the third dimension. The idea of time itself becomes clearer when we understand it in relation to the space we occupy. If we were only in the first or second dimension, our experience of time would be radically different. In the third dimension, we not only experience the present moment, but we can also perceive the past and future in terms of space. For example, we can look back in time by remembering places we've been, or we can think forward to places we might go. The third dimension also opens up possibilities for physical phenomena like gravity. Gravity is a force that acts in three-dimensional space, pulling objects towards each other and causing them to move in relation to one another. It's why objects fall to the ground when dropped. Without this force, the structure of our world would be vastly different. This dimension, with its depth, allows for the interactions that define our physical existence. However, the third dimension isn't the end of the story. While we experience the world in three dimensions, the concept of higher dimensions is a fascinating topic in both physics and mathematics. But for now, the third dimension remains the space we are most familiar with, and it shapes everything from the objects we see to how we experience movement, gravity, and time. So, while the first dimension might seem simple, just a line, the second dimension adds depth by introducing a flat plane. And when you fold that flat plane upwards into the third dimension, you unlock a world full of volume, depth, and complexity. This is the space we live in, where everything we touch, see, and interact with exists. It's a space where we move through time and experience reality in its full three-dimensional form. From the tiniest particle to the vast expanse of the universe, everything that we know exists within these three dimensions. The fourth dimension, time. Time is frequently referred to as the fourth dimension, a concept that challenges how we traditionally understand the world around us. The idea of the fourth dimension expands upon our familiar three dimensions of space: length, width, and height. While we experience space in these three dimensions, time operates differently, seeming to move in one direction only. from the past, through the present, and into the future. Time seems to be a continuous and inevitable flow, one moment following the other without interruption. But when we delve deeper into the nature of time, it becomes clear that it's not as simple as we once thought. Albert Einstein's theory of relativity, first proposed in the early 20th century, revolutionized our understanding of time. In its simplest form, relativity suggests that time is not a constant, unchanging force. Instead, it is influenced by gravity and speed, stretching and contracting based on these factors. This phenomenon, known as time dilation, occurs because time behaves differently depending on how fast you're moving or how close you are to a massive object, such as a planet or a star. At the heart of relativity lies the idea that space and time are intertwined into a single entity known as spacetime. The concept of spacetime suggests that what we perceive as separate, independent dimensions, space and time, are actually linked together in a unified framework. This understanding leads us to a startling realization. The passage of time is not the same for everyone, everywhere. Time can be altered, warped, and even slowed down depending on the circumstances. Einstein's famous equation, E equals mc squared, highlights the connection between energy and mass, but it also plays a crucial role in understanding the way time behaves. The equation suggests that the more massive an object is, the stronger its gravitational pull becomes, causing a curvature in spacetime. This curvature is what leads to the distortion of time. Near a massive object, such as a black hole, time moves much slower than it does far away from that object. If you were to travel close to the event horizon of a black hole, the gravitational pull would slow down time to such an extent that it would appear to stop altogether for an outside observer. Meanwhile, if you were traveling at incredibly high speeds, close to the speed of light, you would experience time differently than someone who remained stationary. This is where things get even stranger. According to relativity, if you could somehow travel at the speed of light, time would cease to exist for you. This is a mind-bending concept. It means that, in a sense, time is not a universal constant. It is not fixed or absolute, as we often assume it to be in our everyday lives. Instead, it is relative to the observer, shaped by the speed at which they move and the gravitational forces acting upon them. The implications of this are profound. It suggests that time may not flow in a linear fashion for all observers. While one person might experience time in a straightforward, unbroken sequence, another person traveling at a different velocity or positioned near a massive object might experience time in a completely different way. This opens up questions about the nature of the past, present, and future, and whether they exist independently of our perception of them. Is time a rigid, unchanging progression, or is it more fluid, with multiple timelines or realities existing simultaneously? As we begin to question the nature of time, we encounter paradoxes and contradictions that challenge our understanding even further. One of the most famous paradoxes in time travel theory is the so-called grandfather paradox. It asks the question, what would happen if you were to travel back in time and prevent your grandfather from meeting your grandmother, thereby preventing your own birth? Would you cease to exist, or would the timeline adjust itself in some way to allow your existence to continue? The very concept of time travel raises numerous possibilities and challenges our intuitive understanding of cause and effect. In addition to time dilation and the possibility of time travel, there's another fascinating aspect of time that remains mysterious: the direction in which it moves. We experience time as moving from the past to the present and into the future. But why does time seem to flow in one direction? This is known as the arrow of time. While we experience the passage of time as a forward-moving process, this is not necessarily a universal truth. The laws of physics are time-symmetric, meaning they do not distinguish between past and future. The equations governing motion and energy work equally well whether time moves forward or backward, yet we never observe time flowing backward. The arrow of time points in only one direction, and we are left to ponder why this is the case. Some theories suggest that the arrow of time is related to the increase in entropy or disorder within a system. In simple terms, entropy refers to the tendency of systems to become more disordered over time. For example, a cup of hot coffee left in a cold room will eventually cool down, with heat dispersing from the coffee into the surrounding air. This process represents an increase in entropy as the energy becomes more evenly distributed. The second law of thermodynamics states that the total entropy of an isolated system always increases over time. This increase in entropy may be what gives time its direction, causing it to flow in one direction, toward greater disorder and randomness. However, this explanation still leaves us with many unanswered questions. If the universe began in a state of perfect order, as some theories suggest, then why did time begin at all? What caused the Big Bang? And what was there before it? Some physicists propose that time itself may have begun with the Big Bang, and that our current understanding of time is limited by our perception of its origins. If time has a beginning, does it also have an end? Is time truly infinite, or does it have a finite lifespan beyond which it may cease to exist? The idea that time is flexible and relative opens up new possibilities for exploring the nature of the universe. While our day-to-day experience of time feels fixed and unchanging, the laws of physics tell us otherwise. Time can stretch, bend, and even reverse, depending on the circumstances. We are still only beginning to understand the full implications of this, and our understanding of time is far from complete. As we continue to explore the mysteries of the universe, one thing remains clear. Time is far more complex than we ever imagined. It is not simply a tool we use to measure the passing of moments. It is a dynamic and ever-changing dimension, influencing everything around us in ways we are only beginning to grasp. In conclusion, time, often called the fourth dimension, is a far more complex concept than we usually assume. Far from being a straightforward, unchanging force, time is influenced by the relative motion of objects, the curvature of space-time, and even the presence of massive objects. It is a flexible, malleable dimension that behaves differently depending on where you are and how fast you're moving. While we continue to wrestle with the paradoxes and mysteries of time, one thing is certain. It is an essential part of the fabric of the universe, one that continues to captivate and confound scientists, philosophers, and curious minds alike. The fifth dimension, alternate timelines. The concept of the fifth dimension challenges everything we know about time and space. Imagine for a moment that time isn't a simple linear progression from past to present to future, but rather something far more complex, a web, intricate and expansive, with countless branching paths. Each path represents a different possible outcome, a different version of events, all coexisting simultaneously. This theory, known as the existence of alternate timelines, opens up a realm of possibilities that stretch the limits of our imagination. In this framework, every decision we make, no matter how small, has the potential to split reality into two or more divergent paths. What would happen if you had taken a different route home today? Or if you had chosen a different career, would there be a version of you living a life that could have been completely different from your own? According to the idea of alternate timelines, there's a reality where that decision has already been made, and you are living that alternate life. In this view, the universe isn't a singular, unchanging story, but an ever-evolving collection of stories, each unfolding from different decisions, different choices, and different events. Think about your own life for a moment. The moment you chose to pursue a particular hobby, move to a new city, or even just speak to someone you never expected to meet, all of these choices have the power to create an entirely new timeline. This doesn't mean these timelines are hypothetical. They could be real, existing parallel to our own. Perhaps in one of these timelines, you took a different career path and now live a completely different life. Or maybe in another timeline, you never met the person who changed your world. The possibilities are limitless, and these alternate realities exist simultaneously with the one we experience. This concept doesn't just apply to individuals, it extends to the very fabric of the universe itself. Events in history, from small moments to major turning points, might have unfolded differently in alternate timelines. Think about the countless what-ifs in history. What if the outcome of a battle had been different? What if a major scientific discovery had come earlier or later? What if a technological breakthrough had never happened? These alternate versions of history could exist, each unfolding in parallel with our own. If we could access these timelines, what would we find? Would they mirror our own reality in some ways, or would they be drastically different? But the most intriguing question that arises from the idea of alternate timelines is whether we could ever travel between them. If multiple timelines exist, does that mean there is a way to navigate between them? Could we somehow shift from one reality to another, stepping into a version of our life where things turned out differently? This idea brings us into the realm of science fiction, but recent theories in physics suggest that such an ability may not be entirely out of reach. One of the most prominent theories that might support the possibility of traveling between alternate timelines comes from quantum mechanics. The many worlds interpretation of quantum physics proposes that every time a quantum event occurs, like a particle's position or state of energy, a new branch of reality is created. Each branch represents a different outcome, creating a vast multiverse of parallel worlds. According to this theory, the universe is constantly splitting, with every decision, every particle interaction creating a new timeline. The universe, as we know it, could be just one of countless realities, each existing in its own parallel dimension. Could it be possible to access these dimensions? Could we travel between them, moving from one version of reality to another? The idea is tantalizing. If alternate timelines exist, then it might be possible for someone or something to bridge the gap between them. Of course, the mechanics of such travel remain entirely theoretical. Physicists and scientists are still trying to understand the full implications of quantum theory, let alone the potential for manipulating or navigating alternate realities. One possible method of accessing alternate timelines involves the concept of wormholes. Wormholes are hypothetical passages through space-time that could create shortcuts between different points in the universe. If these wormholes exist and could be stabilized, they might provide a bridge between different timelines, allowing for travel between them. However, the idea of traveling through wormholes is still far from being scientifically proven. Even if wormholes do exist, it's unclear whether they could be manipulated to allow for travel between alternate dimensions rather than just different points in space-time. Then there's the question of whether we could alter the course of time itself. If we could travel between alternate timelines, would we be able to change the past, rewrite history, and create entirely new futures? The idea of rewriting history is a deeply captivating one, and it's something that has fascinated philosophers, writers, and scientists for centuries. If alternate timelines are a result of different decisions and events, it's possible that we could influence the course of those timelines, potentially altering the trajectory of the future. However, this raises another complex question. If we could change a timeline, would we be able to return to our original reality? What if altering one timeline creates irreversible consequences in another? The very act of changing one path might unravel everything, potentially creating chaos in the multiverse. Some theories suggest that the structure of the multiverse may be so delicate that even a small change in one timeline could have unpredictable, cascading effects on others. The potential dangers of traveling between timelines or attempting to rewrite history are something that many scientists and theorists caution against. If alternate timelines are real, they might be incredibly fragile. A single change could ripple across the multiverse, creating consequences far beyond our comprehension. It's a powerful concept, but one that should be approached with caution. The consequences of altering a timeline could be catastrophic, not just for one reality, but for all of them. But even without the ability to travel between timelines, the very idea that alternate versions of reality might exist is both fascinating and humbling. It forces us to reconsider our understanding of time, reality, and the choices we make. In a world where every decision creates a new branch, every event that could have gone differently, might have its own timeline, unfolding independently. And while we may never be able to travel between these alternate realities, the thought that they exist, somewhere out there, offers a profound perspective on the nature of existence. The fifth dimension isn't just a theoretical concept, it's a way of looking at the universe and our place within it. It challenges us to think beyond the limitations of our linear understanding of time and opens up a new way of imagining reality. In this vast web of branching paths, we are but one thread in a much larger tapestry, and the stories of alternate timelines are waiting to be discovered. Whether we can ever travel between them remains to be seen, but the idea itself is a reminder that reality is far more complex and mysterious than we could ever imagine. The sixth dimension, the universe's blueprint. Imagine standing at the edge of everything you know, your life, your world, and the vast cosmos that stretches beyond, and suddenly being able to see every possible version of reality at once. Every decision you've made, every moment you've lived, every path you've taken, now exists as an infinite array of parallel outcomes. Every possibility you've ever imagined, and those you've never thought of, are laid before you in a single, boundless vision. This isn't science fiction. It's the idea of the sixth dimension, a realm where the limits of our understanding and the fundamental laws of physics begin to dissolve into something far more mysterious. In the simplest terms, the sixth dimension isn't just another place or space. It's the very framework that might govern the potential realities of the universe itself. It's a theoretical idea that pushes the boundaries of how we perceive time, space, and even existence. At the heart of it, the sixth dimension is a realm where all possible versions of our reality coexist simultaneously. But how does that even make sense? Let's dive deeper into this perplexing concept. The sixth dimension is often described as the dimension where the laws of physics as we know them start to lose their relevance. In our everyday experience, we are accustomed to perceiving reality through three spatial dimensions: length, width, and height, and one temporal dimension, which we experience as time. But in the sixth dimension, things take on a far more complex and expansive form. Here, the very fabric of reality begins to branch out, suggesting that what we perceive as our reality may only be one of countless possibilities, each shaped by decisions, events, and outcomes that we might never be able to fully comprehend. One way to think about this is to imagine a decision you've made in your life. Maybe you chose to take a particular job, move to a new city, or pursue a specific relationship. In our familiar three-dimensional world, that choice is a singular moment in time, an irreversible decision. But in the sixth dimension, each of those choices gives birth to an entirely new version of yourself, living a completely different life, based on the path you didn't take. All of these parallel realities coexist in the sixth dimension. The job you didn't take, the city you never moved to, the relationships that never blossomed, they're all present, existing somewhere within the web of the sixth dimension. This is where the idea of parallel universes, or the multiverse, comes into play. In theoretical physics, the multiverse is the concept that our universe is not the only one. Instead, there are countless others, each existing with its own laws of physics, histories, and future possibilities. The sixth dimension is often linked to this concept because it offers a platform for all these different universes to exist simultaneously. Imagine a vast cosmic library, each book representing a different universe, with every possible outcome of every event contained within the pages. The sixth dimension would be the space that connects all of these books, where every story and every possibility is written into the fabric of reality. As we try to grasp the concept of the sixth dimension, it's helpful to consider how our understanding of dimensions works. In our everyday lives, we interact with three dimensions of space and one of time. But physicists have postulated the existence of higher dimensions, places beyond our ability to see or directly experience, yet fundamental to the very structure of the universe. These higher dimensions are not simply extensions of the three-dimensional space we know. They offer entirely new ways of understanding reality. The sixth dimension is often described as a realm that transcends the limitations of our current perception. It's a space where time as we know it can bend and stretch, where alternate outcomes of events coexist, and where reality itself is malleable. Imagine being able to jump between parallel versions of yourself, experiencing each different life simultaneously. In the sixth dimension, there's no clear boundary between what is and what could have been. Every possibility is laid out before you, and the laws of causality no longer apply in the traditional sense. The past, present, and future are not separate. Instead, they coexist in a fluid, ever-shifting landscape, a true reflection of the infinite potential of the universe. But this idea isn't just a wild theory. It has serious implications for our understanding of the universe and everything within it. If the sixth dimension truly exists, it suggests that our reality is far more intricate and interconnected than we could ever imagine. The choices we make, the events we experience, and the paths we walk may not be as final as we once thought. Instead, they might simply be one thread in a much larger tapestry, woven together with all the other possible threads of existence. So what does this mean for the nature of our universe? If the sixth dimension is a place where all possibilities exist, it raises profound questions about the role of consciousness and choice. In a world where every possible version of reality exists simultaneously, do our choices matter as much as we think? Or are we simply travelers within a multiverse of infinite paths, experiencing only one version of the story at a time? The potential implications are mind-boggling. If the sixth dimension allows for the coexistence of all possible realities, it suggests that our understanding of time and space is vastly incomplete. It forces us to confront the idea that we might be living in a tiny slice of a much larger, infinitely complex universe. A universe where every decision we make, no matter how insignificant, branches out into a new reality, forming new worlds with new possibilities. This also brings us to the question of fate. If every choice leads to a new reality, does that mean there is no such thing as fate? Or is fate simply a series of predetermined events unfolding in different dimensions? Perhaps fate is just one possible path among many, a thread that runs through the sixth dimension, but not the only one. In this vast multi-dimensional cosmos, our sense of control and free will could be far more limited than we believe. The sixth dimension doesn't just challenge our perceptions of reality, it invites us to rethink the very nature of existence itself. If all possible outcomes are laid out in the sixth dimension, it hints at a level of cosmic organization that we can barely fathom. It suggests that the universe may not be a random, chaotic accident, but rather a highly structured, intricately designed system with endless layers of potential realities. In the end, the sixth dimension is a reminder of just how much we don't know. It's a glimpse into a universe that is far stranger and more beautiful than we can possibly imagine. A universe where every decision, every possibility, and every outcome is part of an infinite web of existence waiting to be explored. And perhaps, in understanding this dimension, we might come closer to understanding the true nature of our reality. The seventh dimension, parallel universes. The seventh dimension introduces a mind-boggling concept that pushes the boundaries of our understanding of the universe. Beyond the scope of different timelines or parallel versions of our own universe, this dimension opens the door to entirely separate universes, each with its own set of physical laws. Imagine a reality where the laws that govern our own world, gravity, electromagnetism, and even time itself, are not the same. Each universe in the seventh dimension could follow a completely different set of rules, making them fundamentally distinct from anything we know. In this dimension, we might encounter worlds where the forces that bind matter together are different, or perhaps even non-existent, in the same way we understand them. Imagine a universe where gravity doesn't pull objects down to the ground, or where light travels in ways that defy our understanding of speed and direction. In such universes, the particles that make up matter could have properties that allow for behaviors and interactions we could never predict. Some universes might even be built on principles we can't yet comprehend, governed by entirely new types of forces or dimensions. This concept challenges everything we think we know about the fabric of reality. The very nature of what we consider to be real or possible would be shattered in these alternative universes. Take, for example, the fundamental constants of nature that we've come to rely on. These constants, such as the speed of light or the gravitational constant, are the same everywhere we look. But what if they didn't exist in some of these other universes? What if the speed of light was slower or faster? Or maybe time itself didn't progress linearly, but was warped in ways we couldn't even imagine. It's a humbling thought because it suggests that our universe, the one we experience every day, might not be as unique as we think. It could just be one possible reality out of an infinite number, each as strange and alien as the next. Even though these universes might look similar on the surface, their very foundation could be completely different. Perhaps we might stumble upon a universe where life has evolved in ways that are familiar but still foreign to us, where creatures with 6 limbs instead of 4 have developed sentience, or where plants photosynthesize in ways that seem entirely beyond our grasp. It's hard to even fathom how these alternate worlds might operate, as their physical and chemical processes could be unlike anything we've ever studied. What would a planet be like if its atmosphere was made up of gases we couldn't breathe? Or if its oceans were composed of liquid methane instead of water? It's not just the biology and physics of these universes that would differ. The very structure of time and space could behave in radically different ways. Imagine a universe where time moves at a different rate, where 1 second in our world might stretch out into what feels like hours or days in another. Or think about space itself. What if distances between galaxies were smaller or larger? Or if the geometry of space allowed for shortcuts or loops that defy our understanding of travel? Could we visit these alternate universes in the same way we think about crossing the distance between 2 cities? Or would it take more effort than we can even imagine? The possibilities in the 7th dimension are so vast and varied that they seem to extend beyond the limits of imagination. What's more fascinating is that these universes might not just be disconnected, but could interact in ways we are completely unaware of. Could there be some sort of link between them? Perhaps a ripple in one universe causes a chain reaction in another, similar to how disturbances in one part of our universe can have far-reaching consequences. But how would we detect such interactions? How could we observe events unfolding in a universe with entirely different physical laws without the tools we use in our reality? It's a daunting question that challenges the very nature of observation and measurement. The concept of parallel universes in the 7th dimension also brings up the idea of infinite possibility. Each universe could represent a different version of reality, a unique experiment in how the laws of nature play out. In one universe, maybe Earth was never hit by the asteroid that wiped out the dinosaurs, allowing them to evolve into intelligent beings. In another, maybe the conditions for life never existed at all, leaving planets cold and barren. Some universes might even have different forms of life entirely, beings that exist in ways that are beyond the framework of what we consider to be alive. The existence of these universes forces us to rethink the nature of possibility itself. If there are infinitely many universes, then every possible outcome of every event must occur in some form. The choice you make today could lead to a universe where things unfold completely differently. But even though these other realities exist, they are still beyond our reach. We can't travel to them, interact with them, or observe them directly, at least not with our current understanding of physics. These alternate worlds exist in a space and time separate from our own, perhaps even beyond the limits of what we can perceive. This presents an existential question. How do we even begin to comprehend such vast, infinite possibilities? How do we understand the implications of a multiverse that contains worlds so different from our own that we can barely imagine them? And yet, the idea of the 7th dimension forces us to confront the limits of our understanding, to stretch our minds beyond the constraints of what we think is possible. We are left to wonder, if we could somehow peer into these alternate universes, what would we find? What mysteries would be revealed? And what would they teach us about the nature of existence itself? Perhaps the most profound aspect of the seventh dimension is the realization that the universe we experience, the one we call home, is just one of countless others, each with its own set of rules and possibilities. It makes us reconsider our place in the grand scheme of reality. If we are only one of an infinite number of possible universes, then our universe might not be as exceptional as we once believed. And yet, despite the vastness and complexity of these alternate worlds, there is something undeniably awe-inspiring about the idea that we are part of something much bigger than ourselves, a multiverse that stretches beyond the horizons of human imagination. In the end, the seventh dimension offers more questions than answers, more mysteries than solutions. But in that uncertainty lies its beauty. It challenges us to push the boundaries of what we know and explore the unknown. As we contemplate the infinite possibilities of parallel universes, we come closer to understanding not just the nature of the cosmos, but the very essence of existence itself. What does it mean to be part of a multiverse? And what does it mean for us as individuals to live in a universe where anything is possible? These are the questions that the seventh dimension raises, and they continue to captivate the imagination of scientists, philosophers, and dreamers alike. The eighth dimension, laws beyond our own. The concept of the eighth dimension presents a radical departure from the way we perceive reality. It's a realm where the fundamental laws that govern our universe are altered, revealing possibilities that stretch the limits of human imagination. We are familiar with the three dimensions of space and the fourth dimension of time, which together form the fabric of our observable universe. Then there's the fifth dimension, often explored in theories of alternate realities and parallel universes, and the sixth and seventh dimensions, which delve deeper into theoretical physics and alternate versions of events. But the eighth dimension? It is a space where the very constants of nature, the rules that keep our universe running smoothly, are not just different, they're unrecognizable. What happens when gravity, time, and the behavior of matter itself shift? Imagine a universe where gravity behaves differently. In our reality, gravity is a constant force that holds everything together: planets, stars, galaxies, and even light. It's responsible for the formation of everything we know, and its strength is precisely calibrated in our universe. But in the eighth dimension, gravity could be much stronger or weaker. What would this mean? Stronger gravity would make it impossible for stars, planets, and even life as we know it to exist. The intense gravitational pull would crush matter into dense, compact forms, creating a very different kind of universe, one where large celestial bodies could not form or maintain themselves. On the other hand, a weaker gravity might prevent the formation of any structures at all. Stars might not ignite, and galaxies would remain dispersed in a diffuse state, struggling to hold on to any semblance of organization. This new reality could present a world in which the familiar forces of attraction that bring us all together are either too weak to matter or too powerful to allow anything to exist recognizably. Consider the possibility that atoms work differently in the eighth dimension. The way atoms form and behave is the bedrock of chemistry, biology, and all of life. The intricate dance of protons, neutrons, and electrons is responsible for creating all known substances, from the air we breathe to the cells that make up our bodies. But what if this structure didn't follow the same rules? What if, in the eighth dimension, atoms were arranged differently? Perhaps the forces that bind the particles together might be weaker or stronger, leading to entirely different chemical reactions. Elements might behave in ways we can't even imagine, creating compounds and materials that are not only unfamiliar, but could never form in our reality. In this strange universe, life itself might take on an entirely new form, its molecular structure altered in ways we can barely conceptualize. These differences in atomic behavior could lead to the creation of entirely new forms of matter, allowing for complex systems of energy and matter that we have no analogy for in our universe. But perhaps the most mind-bending aspect of the eighth dimension lies in the manipulation of time itself. Time, as we know it, flows in one direction, from past to present to future. It's a constant, unyielding force that governs everything from the movement of planets to the aging of our bodies. But what if time in the eighth dimension didn't work this way? What if, instead of moving forward, time flowed backwards? Imagine a universe where past events unfold in reverse, where cause follows effect instead of the other way around. In such a reality, the concept of cause and effect would be turned on its head, and the very nature of time would cease to be a linear progression. History might unwind itself, with people becoming younger instead of older, and events taking place in reverse order. Perhaps even more fascinating would be the possibility of time looping in a non-linear fashion, where moments overlap or intertwine in ways that break our conventional understanding of reality. Would time still feel like an unchanging, inevitable march forward, or would it become something more malleable, shifting and bending according to the rules of this alternate universe? What is most intriguing about the eighth dimension is that it forces us to reconsider our most basic assumptions about the universe. It suggests that the constants we take for granted, gravity, the behavior of atoms, the flow of time, are not as fixed and immutable as we believe. Instead, they may be the result of our particular set of conditions, existing only because our universe operates under this unique set of rules. In the eighth dimension, those rules are different, and that difference creates an entirely new reality, one that operates outside the boundaries of our current understanding. In this dimension, there is no guarantee that the constants of nature will behave in the same way, or even that they will exist in the same form. This shift in perspective challenges our understanding of the universe on a fundamental level. If the eighth dimension exists, then it is possible that there are infinite variations of reality, each with its own set of laws, constants, and rules. The multiverse theory, an idea that suggests multiple universes with varying physical laws, becomes a very real possibility. These parallel universes, including the one we live in, could be just one of many that exist within this larger, more complex structure. Each universe might operate according to its own set of rules, some of which may be eerily similar to ours, while others may be radically different. The eighth dimension invites us to imagine the unimaginable, to question the very fabric of reality itself. What would it mean for us, as beings who live within the constraints of our universe, to encounter a reality where the laws of physics do not apply in the same way? Could we ever fully comprehend such a place, or would we be left struggling to understand a world where nothing behaves as we expect? The eighth dimension represents an unknown frontier, one that challenges our understanding of science, physics, and reality itself. It also opens the door to endless possibilities. If we could somehow access the eighth dimension, could we manipulate the very laws that govern our universe? Could we change the strength of gravity or alter the behavior of atoms to create new forms of matter? Could we travel through time in ways we never thought possible? The answers to these questions may seem far beyond our reach, but the very existence of the eighth dimension suggests that there are realms of possibility far beyond our wildest dreams. As we continue to explore the boundaries of science and physics, we may one day discover that the eighth dimension is not just a theoretical construct, but a tangible reality, one that could change everything we know about the universe and our place within it. In the end, the eighth dimension represents a profound mystery, one that encourages us to look beyond the limits of our understanding and embrace the unknown. It reminds us that the universe is far stranger and more complex than we could ever have imagined, and that the rules that govern our reality may only be a small part of a much larger, more intricate picture. Whether or not we will ever truly understand the eighth dimension, it is a concept that continues to captivate our imagination, urging us to explore the boundaries of what is possible and to question the very nature of reality itself. The ninth dimension, the landscape of all possible universes. The ninth dimension stands as a profound and almost incomprehensible frontier of reality. It represents a realm where all conceivable universes, each distinct in its own structure and laws, coexist in a unified, boundless expanse. This dimension is not like anything we can grasp within the confines of our three-dimensional world. To understand the ninth dimension, we need to move beyond our everyday experience, reaching into the realms of abstract thought and speculative physics. Picture the universe we inhabit. It is a vast space filled with galaxies, stars, and planets, all bound by the laws of physics that govern them. Time and space stretch outward, creating the reality we observe with our senses. But the ninth dimension does not adhere to this kind of structure. It is not limited by the same rules that bind the space-time continuum as we understand it. Instead, the ninth dimension embodies a state where all possible configurations of reality are realized simultaneously. Imagine, if you will, a series of interconnected bubbles, each representing a different universe. These bubbles float freely within a higher dimensional space, completely independent of one another. Each bubble or universe operates according to its own set of physical laws, which may vary dramatically from the laws we know in our own cosmos. In one bubble, gravity might work in reverse, with objects being pushed away from one another instead of drawn together. In another, time could move backwards or in spirals, creating entirely different experiences of causality. The ninth dimension is the overarching space where all of these bubbles, all of these divergent universes, exist side by side. The ninth dimension is often described in terms of possibilities, where every possible outcome of every event across all timelines is realized. Think of it as a space where all potential realities manifest, where the infinite number of what-ifs become actualities. For every decision made in a universe, every divergence in the timeline, there is a corresponding universe that follows that particular path. In one universe, you might have chosen to go left instead of right. In another, you might have taken a different job or never met a certain person. Each of these decisions creates a new reality, and the ninth dimension holds them all. The sheer scope of this possibility is beyond human comprehension, as it is not simply about the potential outcomes of individual decisions, but about the fundamental laws that govern how these universes could operate. The reality of the ninth dimension goes beyond simple choices, however. It encompasses a vast array of entire realities that are as alien to us as they are to the concept of a single universe. The ninth dimension suggests that every conceivable universe, whether it follows the rules of physics we know or operates under entirely different principles, has an equal existence. There could be universes that follow the same laws of gravity and thermodynamics as our own, but with variations that lead to entirely different outcomes. For example, there could be universes where time flows in a loop, where the past and future coexist in a never-ending cycle. There could be realities where beings of pure energy exist, or where entire galaxies are in a state of perpetual motion, never at rest. In many ways, the ninth dimension challenges our very understanding of reality. The idea that there could be infinite versions of ourselves, all living in alternate universes that are structured differently, is both captivating and unsettling. What does it mean to exist in such a reality? If every possible version of you exists in some universe, does that imply that you have no control over your fate? In a sense, the ninth dimension suggests that our lives are merely one of countless possibilities, each unfolding in parallel with others. But this realization does not render our existence meaningless. Instead, it encourages us to think more expansively about the nature of our universe, our choices, and our potential. This realm of infinite possibilities is a space where reality is not limited by any physical constraints. It is as if the ninth dimension operates according to a completely different set of rules, where the laws that govern time, space, and matter in our universe simply don't apply. In a way, this makes the ninth dimension both an abstract concept and a concrete one. It is abstract in that it cannot be directly observed or measured by our current scientific instruments, but it is concrete in the sense that it represents a fundamental aspect of reality, a place where all possible realities exist in harmony. The question of how the ninth dimension relates to our universe remains a topic of intense speculation and scientific inquiry. Some theories suggest that our universe may be a tiny part of this vast multiverse, a small bubble within an ocean of possibilities. Others propose that our universe may be just one of an infinite number of bubbles that interact with one another in ways that we cannot yet comprehend. What is clear, however, is that the ninth dimension suggests a level of complexity that far exceeds our conventional understanding of reality. It points to a universe that is far larger and more intricate than we could have ever imagined, where the possibilities are truly endless. As we explore the implications of the ninth dimension, we are confronted with some profound philosophical and existential questions. If every possible version of reality exists, then what does that mean for the choices we make? Are our lives simply the result of chance, or do we have some influence over the direction in which our universe unfolds? The ninth dimension suggests that our choices may be part of a larger, interconnected web of possibilities, but it also invites us to consider the role we play in shaping our reality. This concept challenges the idea of a single, fixed universe where events unfold according to a predetermined sequence. Instead, it suggests that reality is fluid, dynamic, and ever-changing. Every decision and every action creates new possibilities, leading to the formation of countless alternate universes. This brings to light the idea that reality is not a static, unchanging structure, but a living, breathing entity that is constantly evolving, with an infinite number of potential outcomes. The ninth dimension, in all its complexity and mystery, is a realm that stretches our understanding of what is possible. It is a place where the laws of physics as we know them no longer apply, where every conceivable version of reality exists simultaneously. It invites us to question the nature of existence itself, to explore the infinite possibilities that lie beyond the limits of our perception. While we may never fully understand the ninth dimension, the very idea of its existence challenges us to expand our thinking and embrace a reality that is far more complex and wondrous than we could have ever imagined. In the end, the ninth dimension is not just a concept to be studied, but a reminder of the vastness of the universe and the boundless possibilities that await discovery. The 10th dimension, the ultimate everything. The 10th dimension is the ultimate level of existence, where everything converges into one unified whole. It represents the highest boundary of our understanding, a realm that transcends every physical and abstract concept we know. To comprehend the 10th dimension, we must first accept that our perception of reality is limited, tied to the 3 dimensions of space and the 4th dimension of time that we experience daily. But what lies beyond this familiar reality is a vast and complex structure that stretches the imagination beyond the edges of conventional physics. In the lower dimensions, we can visualize things that we can touch, see, and measure. The first dimension is simply a straight line, a single point with no width or depth. The second dimension introduces length and width, creating flat shapes like squares and circles. The third dimension adds depth, forming the world we interact with, where we can perceive objects in 3D space. The fourth dimension, time, gives our world a timeline, allowing events to unfold. These dimensions are the ones we can grasp, the ones we experience directly. But these dimensions, while infinite in their variety and complexity, are still just the building blocks of something far larger. The fifth dimension expands the possibilities of reality beyond our comprehension. In this realm, different versions of our lives and decisions coexist, suggesting that for every choice we make, countless other versions of ourselves exist in parallel realities. It's a dimension where every possibility plays out. Every outcome of every action exists as an alternative version of you. The sixth dimension introduces even more complexity, where instead of just different realities branching off from our choices, entire universes exist based on the laws of physics that differ from our own. These universes might have different forces, different constants, and even different versions of life. The seventh dimension then goes further, where not just alternate laws of physics exist, but also different dimensions themselves, with entirely separate spaces where the fundamental fabric of reality is not constrained to what we know. The eighth dimension expands even further, where you no longer simply move through time and space in the way we understand it. It allows for the creation of entirely different timelines and physical constants, offering an almost infinite number of universes where things may be completely alien to our understanding. The ninth dimension stretches the boundaries even more, where time itself can bend and fold, and multiple versions of the laws of physics are not just possible, they are present, interwoven into the very fabric of what we call existence. At this point, the line between what is and what could have been blurred into a limitless continuum of potential realities. And then, at the edge of this vast conceptual space, lies the 10th dimension, the ultimate everything. It is the dimension that contains all others, the one in which everything that exists, or ever could exist, converges into a single, incomprehensible whole. This dimension doesn't just hold every possibility, it is the embodiment of every possibility. Every universe, every law of physics, every moment in time exists here simultaneously. The 10th dimension is not bound by the constraints of any physical laws. It is the source and the end of everything that can be imagined. It is the library that contains every book ever written, and every book that could ever be written. To put it into perspective, imagine the entirety of existence, not as a collection of random, disconnected moments, but as a single entity, a vast, intricate web where each thread represents a different aspect of reality. In the 10th dimension, all these threads are woven together, forming a tapestry of such complexity that it becomes impossible to comprehend in its entirety. Every possible configuration of time and space is present. Every possibility that has ever been imagined, or ever could be imagined, exists in its purest form. There are no boundaries to what can exist, no limit to the variations that can occur. Every version of every universe, every path that might be taken, and every alternative that could ever arise is present in the 10th dimension, existing in a simultaneous state of being. This dimension holds not just the potential for everything, but the actuality of everything. In this realm, time does not flow as we know it. There is no past, no present, no future. All moments, all events, and all possibilities exist as part of one eternal, unchanging whole. It's a space where every what-if becomes a reality, where every path taken and not taken is lived out in parallel. And yet, all of this exists as one singular entity, a point where the past, present, and future converge into one infinite point of existence. The 10th dimension is not just a theoretical construct. It is the very framework of the cosmos, holding everything within it. One of the most perplexing aspects of the 10th dimension is that it challenges everything we think we know about reality. In our three-dimensional world, we see time as linear. We experience the flow of events one after another, but in the 10th dimension, this flow doesn't exist in the same way. Time is a construct, not a flowing river. It's a fixed entity, where all moments in time are part of the same eternal expanse. Every moment exists, not as a point on a line, but as a component of an infinite, interconnected whole. In the 10th dimension, the very concept of time and space becomes irrelevant because they are not separate entities, they are part of the same all-encompassing existence. In many ways, the 10th dimension is the ultimate paradox. It is the culmination of all that exists and all that could exist, and yet it is beyond our ability to truly understand. It is beyond our senses, beyond our logic, and beyond our comprehension. It exists in a space that transcends the boundaries of language, thought, and perception. It is the realm of everything and nothing, where all that is possible and impossible comes together in a way that we cannot truly grasp with our human minds. The 10th dimension is both the origin and the end of all things, the ultimate level of existence, a level of reality where every universe, every possibility, every moment, and every law of physics coalesce into one incomprehensible whole. It is the ultimate everything. To think of the 10th dimension is to acknowledge that the universe is far more complex and far more interconnected than we could ever imagine. It reminds us that there is always more to discover, always more to explore, and always more to learn about the nature of existence. The 10th dimension is the highest level we can currently conceive, and it is a reminder of how vast and mysterious the universe truly is. It is the place where everything converges into one single entity, a single, infinite, and eternal reality. And while we may never fully understand it, we can marvel at the fact that it exists. Here's where your mind starts to unravel. If the 10th dimension encompasses every possible universe and every conceivable outcome, then nothing is random. Every event, past, present, and future, has already unfolded in some form. This suggests that everything we've experienced and everything we're going to experience is part of an already existing pattern, woven into the fabric of a universe we can't fully grasp. In this framework, reality as we know it may be nothing more than an illusion, a fleeting fragment of a much larger, incomprehensible system. But if everything that can happen already exists somewhere, what does that mean for us? Are we truly making choices, or are we simply following a path that's already been written? Our decisions, our actions, everything we think we control, could they all just be the result of a script that plays out somewhere in the vast multiverse? The idea that free will is an illusion is terrifying but also mind-blowing. If every possibility is already accounted for, does that diminish the meaning of our lives? Or does it make everything more profound, knowing that in some form, every choice and every moment exists eternally in the tapestry of the multiverse? The implications are staggering, and the more you try to make sense of it, the less it seems possible to comprehend. The 10th dimension, with its infinite versions of reality, challenges everything we've ever believed about existence. It leaves us questioning, are we living the life we choose, or is everything predestined within the infinite possibilities of an all-encompassing universe? Modern physics is only starting to explore the vast implications of higher dimensions, and we are just beginning to grasp how these dimensions could reshape our understanding of reality. Theories like string theory challenge our perception of the universe by suggesting that these dimensions are not mere mathematical concepts, but fundamental components that could influence the very forces that govern everything around us. The idea that there are more than the 3 dimensions we experience daily could revolutionize everything we know about the cosmos. If, in the future, we develop the technology or understanding to manipulate these hidden dimensions, it could completely transform our approach to space travel, enabling us to explore the farthest reaches of the universe in ways previously thought impossible. We may also gain the ability to influence or even alter the flow of time, something that has long been considered the realm of science fiction. At this point, much of what we know about these higher dimensions is speculative. We have only begun to peer into this unknown territory, and the more we learn, the more complex and mysterious it becomes. As our tools and theories advance, we might uncover layers of reality that fundamentally challenge our conventional understanding of space, time, and the very nature of existence itself. Yet, despite the excitement of these possibilities, we are still left with far more questions than answers. Every discovery seems to reveal even deeper layers of mystery, showing that the universe operates on levels far beyond our current comprehension. What we can be sure of, however, is that the universe is far more bizarre and vast than we have ever imagined. These higher dimensions, if they truly exist, hold the potential to unlock mysteries that could change humanity's place in the cosmos. The journey to understand them is just beginning, and while we may not have all the answers yet, the pursuit itself promises to reveal an entirely new perspective on the universe and our existence within it. The quest for knowledge, once again, proves that the universe is not just larger than we think, it's larger than we can even begin to imagine. And that's a wrap on today's exploration of the quantum physics behind 10 dimensions. The mysteries of the universe are just beginning to unfold. Subscribe now to continue this journey into the unknown with more captivating content.